All right, so here we are. We have this phase diagram, and we have a bunch of regions on this phase diagram that we want to label. Now, you could just start at A and then go B, C, D, E, F. You might have a hard time with that. So instead, what we're going to do is we're going to start by figuring out our regions. Which region of the phase diagram is solid, liquid, or gas? And that's going to help us figure everything else out. Now remember, the particles in solids packed very tightly. And so that's going to happen at high pressures and low temperatures. So high pressure, low temperature, solids are generally going to be in this corner of a phase diagram. Now I look at the other extreme, low pressures and high temperatures. Low pressure is going to allow more and more space between my particles. And high temperature, more and more kinetic energy for those particles. And that is most like a gas. So gases have a lot of distance between particles and a lot of energy, kinetic energy for those particles. So this corner is going to be my gas corner. So F, the letter F, is my solid region because it contains that high pressure, low temperature corner. And then the letter H is going to be my gas region because that contains my high temperature, low pressure corner. And then, of course, the region in between, G, represents a state of matter in between solid and gas, which hopefully at this point we all know is the liquid. From here, we can start figuring out all of these lines, right? Let's look at B. This represents this transition between F and G, which is solid and liquid. So B, what word do we use for the transition between solid and liquid? We can use melting or freezing. They describe the same process in different directions. So this is my melting, freezing line or boundary. And what that means is that at all of these temperature and pressure conditions, this substance will be transitioning between solid and liquid. So now let's look at C. This represents the transition between liquid and gas. What do we call that? We call it boiling, or we call it condensing. Same process, different direction. So C is my boiling condensing line. Or boundary. Now let's look at A. That's this line. It represents the transition between my solid region and my gas region. Now it's small, but it's there. What do we call the transition from a solid directly to a gas? We call that sublimation, or the opposite, gas directly to a solid, is deposition. So A is my sublimation, deposition, line or boundary. Okay, we got two more. We got D, which is this point, and we have E, which is this point. Now D, hopefully, is pretty straightforward. It's where all three of my boundary lines, A, B, and C, intersect. So at that point, at this temperature and pressure, at D here, we see all three phases of matter represented. That is our triple point. And then E represents sort of the end of my boundary line between gas and liquid. Beyond E, we enter what we call the supercritical region. And so E is my critical point. At temperatures and pressures beyond this point, this substance will behave as a supercritical fluid. And I hope you looked at that video on the last slide.